Hello everyone, welcome to this video of
File fit, combined open angular and sliding sides.
In the previous video, we understood the procedure to make a sliding T-fit with interchangeability. We also learned about the limits, fit and tolerances. In this video, we will learn about angular measurement, geometric tolerances on shape or form, orientation and position used to file and fit combined open angular and sliding slides.
Angular measurement of angles of an object is usually expressed in degrees, minutes and seconds. 1 degree is divided into 60 minutes and 1 minute is into 60 seconds. The tool used to measure angles accurately with precision is the vernier bevel protractor. The vernier bevel protractor is a precision instrument meant for measuring angles to an accuracy of 5 minutes. The following are the parts of a vernier bevel protractor. Stock. This is one of the contacting surfaces during the measurement of an angle. Dial. The dial is an integrated part of the stock. It is circular in shape and the edge is graduated in degrees. Blade. This is the other surface of the instrument that contacts the work during measurement. It is fixed to the dial with the help of the clamping lever. Locking screws. 2 knurled locking screws are provided. One to lock the dial to the disc and the other to lock the blade to the dial. The vernier bevel protractor is used to measure acute angles less than 90 degrees and obtuse angles more than 90 degrees. The tolerance on size is also called as dimensional tolerance. But these tolerances may not be sufficient to manufacture the desired fit perfectly. So, we require additional tolerances called geometrical tolerances as shown in the example. These are of following 3 types: tolerances on shape or form, tolerances on orientation, tolerances on position. The geometrical tolerances is represented in terms of symbol, tolerance value and reference datum. Let us see tolerances on shape or form with the following characteristics. Straightness. It is the characteristic of a line where all the elements of a line are collinear. In general, there could be 2 lines within which all the points lie on a line. Flatness. It is defined as minimum distance between 2 planes within which all the points lie on a surface. A surface where all the points lie along single plane is called as perfectly flat surface. Circularity. It is defined for a cylindrical or conical surfaces as the distance between the surface and its axis. Ideally, all points on a surface at a cross-section should be equidistant from the axis for the cross-section to be perfectly circular. The tolerance on circularity is defined by 2 concentric circles within which a surface can lie. The distance between the 2 concentric circles is called tolerance. Cylindricity. It is defined for a surface of revolution as the distance between the surface and its axis. Ideally, all points on a surface of revolution should be equidistant from the axis for the cross-section to be perfectly cylindrical. The tolerance on cylindricity is defined by two concentric cylinders within which a surface can lie. The distance between the two concentric cylinders is called tolerance. Profile of line or surface. It is defined for a line or surface of any shape as the distance between two lines or surfaces of the same shape as that of the line or surface in question, separated by a distance equal to tolerance. Tolerances on orientation. Parallelism. It is defined for a feature like surface or line with reference to another feature called reference. It defines the distance between two lines or surfaces that are parallel to each other and parallel to the datum surface and encompass the line or surface in question. Perpendicularity. It is defined for a feature like surface or line with reference to another feature called reference. It defines the distance between two lines or surfaces that are parallel to each other and perpendicular to the datum surface and encompass the line or surface in question. Angularity. It defines the distance between two lines or surfaces that are at an angle to the datum surface and encompass the line or surface in question. With respect to position, it defines the perfect exact location of a point, line, or a surface in relation to the other datum. Concentricity. It defines the position of an axis in relation to the other datum axis. It defines a cylinder which coincides with the datum axis and of diameter given by the geometrical tolerance. Run out. It defines the deviation from the desired form and orientation during one full rotation of the part on the datum axis. Let us now learn the procedure to file and fit open angular and sliding sides of mating workpieces. Check the raw material for its size. File part 1 and 2 to overall size of 78 by 48 by 9 mm, maintaining parallelism and perpendicularity. Check the size with vernier caliper. Apply marking media and mark dimension lines on part 1 and 2 as per job drawing. Punch witness marks on part 1 and 2. Hacksaw and remove the excess metal in part 1 and file to size and shape, maintaining accuracy of plus or minus 0.04 mm and angle of 30 minutes. Drill diameter 3 mm relief hole in part B. Chain drill. Chip, remove the excess metal in part B and file to the size and shape. Check the size with vernier caliper and angles with vernier bevel protractor. Finish file on part 1 and 2 and deburr in all corners. Match part 1 and 2 as shown. Apply a little oil and preserve it for evaluation.
In this video, we learned how to take angular measurements and use of vernier bevel protractor, concept of geometric dimensioning and tolerancing GD and T,
How to file fit combined open angular and sliding sides of mating workpieces.
Thank you for watching.